Good morning, great viewers. You're welcome to today's edition of the mathematics class. I want to give you a recap of all we have done this term in GS3 mathematics. So this video is actually aimed at making a summary of all that we have learned in our scheme in second term. Now the first topic on our scheme, the first topic on the scheme is factorization. Factorization. Alright. Of course you already know what factorization is. Like I said, this is just a summary of what we have done in the previous class. Now, what is factorization? Factorization can be done in so many ways. Factorization can be done in so many ways. Now, factorization can be seen in what I call difference of two squares. Difference of two squares. Of course, you know what that means. The difference of two squares. Now, how do you know if a particular expression is in difference of two squares? How do you know if a particular expression is in difference of two squares? Okay, take for example, if I have x squared minus y squared, this expression is said to be in difference of two squares. That's x squared minus y squared. But how do you express this? It can be expressed as x minus y bracket x plus y. That is, x squared minus y squared can also be written as y minus x minus y brackets open and close x plus y. Okay, now we can also have other forms of factorization in difference of two squares. For example, if I have 4x squared plus or minus 9y squared, I can also present this expression in difference of two squares. I can also present this expression in difference of two squares. How do I do that? X, of course, is already in square. Y4 can also be expressed as 2 squared. 2 squared, y squared minus 3 squared, y squared. Now, this expression can also be written as 2x all squared minus 3y all squared. Of course, you have broken this expression down in the form of difference of two squares. Then it can now be expressed as 2x minus 3y bracket open and close 2x plus 3y. So that is all about difference of two squares. Then let us look at factorization as it concerns quadratic equations. Let's look at factorization as it concerns quadratic equation. Now, mind you, how do you recognize an expression in quadratic? How do you know that a given expression is in quadratic form? Now, an expression is said to be in quadratic form when it is of the form ax squared plus bs plus c equals 0. Now, whenever you have this expression is said to be in quadratic form. It's said to be in quadratic form. Of course, you already know that there are different methods that can be applied to solve problem in quadratic expression or equation. This expression, like I said, is in quadratic form. Okay, now let us look at factorization in quadratic expression. How do you factorize a given expression in quadratic form. For example, if you are given x squared plus 5x minus 5x plus 6. Now, this expression, how can it be factorized? How can this expression be factorized? Now, for you to factorize a given expression effectively, you have to first of all consider the first step. Okay, I've forgotten to tell you that in a quadratic expression, we have the first term, we have the second term, and we have the third term. Now, the first term here is the coefficient of x squared. And also, don't forget that a quadratic equation is an equation whose highest degree of the variable is 2. What I'm saying is, the variable here is x. And you can see that the power of x, the power of x here is 2. If the power of x is less than or greater than 2, then such equation cannot be said to be a quadratic expression. Okay, having said that, let us look at this equation. How do you solve this question? With factorization method. How do you solve this question using factorization method? First of all, let's look at the question. Is the question factorizable? Is it a factorizable quadratic expression? That is what we should aim at doing right now. Okay, let's look at the equation. We have x squared minus 5x plus 6. 5x plus 6. Now, the equation, we look at the coefficient of x squared. The coefficient of x squared here is so important because it's going to determine the outcome of your solution. Now, the coefficient of x squared here is 1. Now, we will consider the coefficient of x squared, which is unity, then multiply it by the last term. The last term here is 6, which means that we are multiplying this whole thing by 6, which is equal, if you multiply 6 by x squared, you are going to have 6x squared. If you multiply x squared times 6, you will have 6s squared. That's what you're going to have. You're going to have 6s squared. Then, now, this is the middle term. This is the middle term. The middle term here is minus 5x. So we are looking for two factors that will produce 6s squared. What are the two factors that will likely produce 6s squared? The factors, we are looking for two numbers that when you multiply together, when you multiply two numbers together, it will give you 6s squared. Let's look at the number. Okay, first of all, we can look at 2 and 3. 2 and 3. Now, 2 and 3, when you put 2 times 3, will give us 6. 2 times 3 will give us 6. And minus 2, minus 2x minus 3x will give us minus 5x. Now, you can see that the two factors which we have chosen, which is 2x squared and minus 3x squared, are the factors that we are going to use to factorize this variable. So in that case, you are going to substitute minus 2x and minus 3x. So we're going back to the expression. We'll now write x squared minus 5, instead of writing 5x, you replace it with 2x. So we are replacing 5 minus 5x with 2x minus 3 plus 6. So now we will now group this. We'll group it into two places. Now, here if you look at the common expression here, if you look at this bracket, you find out that something is common. And what is common is what? Is If you factorize s, or if you bring out s, you will be left with s minus 2. And here, what is common here? 3 is common. 3 is common to both sides. So you bring out 3, you pull out 3, and you are left with x minus 2. Now, the minus sign here has affected the minus sign in the bracket and change the sign to minus. So you have s minus 3. This s minus 3, you write it down. Then pick any of these. Now, what you have within the bracket must be similar. What you have within the bracket must be similar. Must be similar in every term. So here, because they are similar, you pull out 1. That is, you just write out x minus 2. You pull out you pick 1 out of this plus x. So by this, you have factorized this quadratic expression. So the solution to this question is x minus 3 and what? X minus 2. So we can also pick another question to further buttress this topic. We can pick the question. Let's get the question. Now I have a question here. The question is, is s squared plus 7x plus 12 minus 7x plus 12. This is our question 2. We have s squared minus 7x plus 12. Alright, again, you are multiplying this term by the last term. That will give us 12x squared. Then we're looking for two numbers that will give us that when you multiply together, it will give you 12x squared. And the same number, when you add or subtract them together, it will produce minus 7x. Now, the number that comes to mind is 3 and 4. Let's see. 3x times 4x will produce 12x squared plus 12x squared. Of course, we are gotten this. And minus 3x minus 4x will produce plus 12x squared. And minus 3x minus 4x will give us minus 7x. So these are the factors. So the factors here are minus 3x and minus 4x. So we going back to the expression, and the expression we have here is s squared minus 7x plus 12. So we are replacing minus 7x with these factors. So we have s squared minus 3x minus 4x plus 12. Of course, you have to group them into two brackets. Like this. So we look at what you have within the bracket. We have s squared minus 3x. Of course, we're going to pull out the common factor. The common factor here is x. And you write down the remainder. We also pull out the common factor here, which is 4. Right hand the remainder. This sign will affect this sign. 3 minus 8. This 3. So looking at it, we'll have s minus 4. And you pick any of these, s minus 3. So by this, you have just factorized that expression. Like I told you, this video is aimed at summarizing our scheme of work for second term class. Alright, we will do well by considering other aspects of the scheme. And we are going to look at simple equation in will further buttress what we have already done in the past. Alright, so let us look at this question. Let's look at this question. Equation. Simple equation. Simple equation with fractions. With fraction. Simple equation with fraction. Okay, we're looking at the first question. The first question here is a very simple one. Simplify or solve the following. Solve the following. Solve the following. Now the first question here is 2x over 15 equals 4 over 5. It's a very simple case. Of course, when we have this, what do you do? It's a very simple case. You cross multiply. We cross multiply. Now what do you do? Now, when you cross multiply, of course you have 2 times. You have 2 times 5. Then you have 4 times 15. Cross multiply. 2 times 2x times 5 equals 10x. And 4 times 5 will give us 4 times 15 will give us 50. Of course, we divide both sides. Dividing through by 10. Dividing through by 10, we have 10 over 10 is 50 over 10. And 10 will come from 10, then x is equal to 6. Like I said, simple case. Let us consider another question. Now, to consider another question here, we look at probably a question that is a bit complex, like 2 over x minus 1 over 3 equals 5 over 6x. Now, if you look at this equation, of course, it's a bit different from what we have solved before. It's different from what we have solved before. Here, we look at, first of all, you can solve this question in so many ways. You can decide to take the SCM of all the denominators. We have 3 fractions in all. You can decide to take the SCM of the three denominators here. Talking about 3 x, 3 and what? 6x. So when you take the SCM of these 3 denominators, of course, s into x give us 1. S into 3 give us 3. S into this, to reduce this to 6. Then what can go again? 2 can go. 3. What can go again? 3. So at the end of the day, you find out that the LCM of these three fractions is x times 2 times 3, which is 6x. So the LCM of these fractions, the LCM of this fraction is nothing but 6x. So how about the LCM? The LCM of the fraction is 6x. So in that case, we are multiplying each fraction. Multiply each fraction by this LCM by 6x. So you are multiplying 2x by 6x. You multiply 1 over 3 by 6x. You also multiply 5 over 6x times 6x. So going by this, of course, as we cancel x here, and then you're left with what? 2 times 6 minus 3 here, 1, 3 here, 2x. So you're left with 2x here. And over there, 6 cancel 6, you're left with 5. So these 2 times 6 will give us 12 minus 2x equals 5. So we'll collect like terms. We'll collect the like terms. Have 12 minus multiplied by 2 give us x equals 7 over 2. 7 over 2. So the solution to that question is 7 over 2. Of course, which is the same thing as 3 over 1 over 2. You can check if your answer is correct. Check if your answer is correct by substituting the solution you have here into this expression. Of course, something that we have done in class, I expect you to have known it. Alright, like I said, we are making a recap of all the topics that we have already studied in our previous class. Now, I'll take on this topic, simultaneous equation, just to wrap up this section. I'll take on the simultaneous equation just to wrap up this section. Now, talking about simultaneous equation, you all know that to solve simultaneous equation involves two or three distinct methods. For you to solve simultaneous equation, it involves three distinct methods. Now, what is the meaning of the word simultaneous? The word simultaneous means doing two things at the same time, solving two equations at the same time. So, how do you recognize or identify a simultaneous equation? How do you identify a simultaneous equation? Now, when an expression is of this form, for example, you have an expression that is of this form, let's say this is the group over here, 5 and 6. Now, you can see that there are two equations, there are two equations here. Now, these two equations are said to be in simultaneous equation. They are said to be in simultaneous form. Now, what are the methods? What are the methods we can apply in solving a simultaneous equation? Number one, we talk about the elimination method. We can easily apply the elimination method to solving a simultaneous equation. We can also apply substitution method in solving a simultaneous equation. Then thirdly, we can apply graphical method in solving a simultaneous equation. So let us consider the first case. Now let's consider this question. Solve number one. Solve this question using elimination method. Solve this question using the elimination method. And the question is 3x minus y equals 5. And the second question is 2x plus y equals 5. Now, looking at these two equations, of course, this is your equation 1, this is your equation 2. Now, the word elimination has to do with what? With a removal. The word elimination means to remove something from a given expression in order to give way for the order to be found. Of course, there are two variables here. We have x and y variables. So you look at the variables that you can easily eliminate here. So looking at this expression, you will find out that it is easier to eliminate the y variable than the what? Than the x variable. So using the elimination method here is so simple. You will say add equation 1 to equation 2. So when you add the two equations together, obviously you're going to have 3x plus 2x minus y plus y, 5 plus 5. So 2x plus 3x or 3x plus 2x equals 5x minus y plus y equals 0. So this is eliminated as the name implies. 5x is now equals to 5 plus 5, which is 10. Of course, the value of x can be found by this moment. Of course, the value of x will be 10 over 5, which is 2. So by this, you have found the value of x. Now, again, you can easily find the value of y when you fall back to equation 1. Equation 1 above is 3x. Is 3x minus y equals 5. Remember, we are putting the value of x to be 2. So, substituting the value of x into equation 1 will enable you to find the value of y. So that will give us 2 into 3 into 2 minus y equals 5. Of course, we have 6 minus y. So finally, we have 6 5 equals 1. So the value of x, the value of y will finally be equal to 1. So you have succeeded in finding the value of x and then y. Thank you very much. And I think with this few summary, you'll be able to learn one or two about the topics for this period. Thank you very much.